and welcome back to Algebra 1. Our goal for today is to continue working with our solving when we have multi-step equations and inequalities. And more specifically today, when we add in our inequality problems that are bigger or more complex than a 1 or 2 step, can we use distributing and combining like terms to get it back to an inequality that we know how to solve? And remembering always our no flip rule that we have to remember when solving inequalities. At this point, I should fully understand that an equation is always in the format of expression, equal sign, expression, and inequality is in the format of expression, inequality sign, expression. So today we're looking at problems that look like this with greater thans, less than, greater than or equal to's, and less than or equal to's. Please remember, when we solve inequalities, we tend to usually make a picture version of the solution when we're done because there's usually a set of solutions or an infinite amount of solutions, and it's hard to describe just in that inequality statement. So usually we use a picture version so that we have a visual representation of all the possible solutions. We are going to do that task again today. Please remember, when you multiply or divide by a negative number, you need to flip the direction of your sign. Some of us missed this on our previous learning or previous activities and previous assessments. So please make sure we're always thinking about that. When do I keep the sign the direction that it currently is? And when do I have to flip it to get to the sign that would get me to my correct solutions? So our goal for today, our problems are going to be bigger and more complex than a 2-step, which might require some simplifying by distributing and combining like terms before we work on our inverse operations. Step 4 down there suggests to write your final answer in variable first order. A few of us didn't do that on some of our previous assessments, and it caused us to color the wrong solutions on our graph. So my suggestion is take the time to put that variable in front, the number in back, and get your sign pointing in the direction that will most help you color or shade in your solutions. Because once your variable is in front, then these rules apply. So if the variable has to be listed first for these to be your resulting graphs, so be careful. So I have a letter bigger than something, then I would shade to the right. If I have a letter less than something, I would shade to the left. Right? If I have a letter bigger than or equal to, I would have a closed in and shade to the right. If I have a letter less than or equal to, I have a closed in and shade to the left. However, if these were flip-flopped, right, that would not be the resulting graph, so be careful. All right, so number 1, can we solve for x when we have the inequality x plus 5x minus 5 is greater than 1? All right, this is definitely bigger or more complex than just a 2-step problem because we have some simplifying that we could do here first. So we want to combine like terms. This is a 1x, right? There's no distribute here, but we have 2 things that have x that can go together. So 1x plus 5x would give us a total here of 6x minus 5 is greater than 1. All right, nothing else to simplify. So now we would find our sign with our variable. Inside of there, we have a multiply and a subtract. So this is going to take 2 inverse operations to help us solve from there. I cover up my x term. I need to get rid of a subtract 5 first. Add, and the amount is a 5 to both sides. Adding and subtracting will never flip the direction of our sign, so that's going to stay as a greater than on this step. So we have 6x is greater than 6. All right, our next step is our multiply, divide step, and our check to see if it's a flip step. All right, so right now we have a multiply by 6. We're going to divide. And we're going to divide by positive 6. Since our dividing number is a positive, no flip. So this is going to stay as a greater than. So 6x divided by 6, staying as a greater than, and a 6 divided by 6. All right, when we're done here, we end up that x is every number greater than 1. All right, we want to make a picture version on your, if you're working on a Google slide that I've created for you, I've put a text box here for you to fill in your number, which is a 1. Very similar to how it looks on Get More Math. If you're working on a piece of paper where you see the entire number line with tick marks, then I'm asking for 2 numbers on each side. So 0, -1, a 2, and a 3. And those two numbers on either side should be exactly numbered correctly as if it were a correct number line. Don't skip around. Don't just pick any numbers you want here, right? I want a proper number line. All right, from there, open circle, and we want things greater than 1, so we should be shading to the right. All the way to positive infinity, so don't forget that arrow on the end. All right, number 2, we have a inequality here that's bigger or more complex than a 1 or 2 step, so we need to go through our process of simplifying it back to a 1 or 2 step inequality. In this case, there's no parentheses, so there's no place to expand using the distributive property. But again, there are some like terms. Let's combine. We have this term that has a variable t, and this term of negative 10t. Those are like terms that can go together. So 13t minus 10t would give us 3t. We still have the subtract 7, and it's still a less than 2. Nothing else now to simplify. So from my side where t is, inside that box, there's a multiply and there's a subtract. So this is, again, a 2-step inequality from here on out. I cover up my t term. What I can still see is a subtract 7, which is the thing I need to get rid of or remove first using inverse operations. So we're going to add, and the amount is a 7 to both sides. All right, cancel on the one side, bring down our 3t is less than. 2 plus 7 would just give us a value of 9. All right, our next step is our multiply divide step that might cause a flip. So please make sure you're always thinking when I do my multiplication or I do my division step, I have to check to see if my sign stays or if it flips. So in this case, we're going to be dividing by a positive 3. Right, this number here is positive, so this again is a no flip. This is going to stay as less than. All right, that means that t then is every number less than 3. Let's graph our solutions. 3 in the middle, 4 and 5 would be our numbers getting bigger. 2 and 1 would be our numbers getting small. Open circle at 3, and since we want things that are less than, we should be shading everything to the left, right? 2, 1, 0, negative 1, negative 2, all the way until we get to negative infinity. All right, number 3. 15 is greater than or equal to 3n minus 40 plus 2n. Again, this one does not have any parentheses, so there's no place to expand using the distributive property. So we want to go straight to combining like terms. Over here with the side that's just 15, there's nothing to combine, so it's going to stay as 15. The greater than or equal to needs to come down in between. We have a term of 3n and a term of 2n that can go together. That would give us 5n minus 40. All right, since we're done simplifying, focus on your side with n, which is the side behind the inequality sign. We have 2 things in there, a multiply and a subtract. So I cover up my n. I need to get rid of the subtract 40 part first by adding 40 to both expressions. We have a 15. We're going to add 40 to it. And we have an expression over here of 5n minus 40 that we also need to add 40 to. All right, cancel on the one side. Bring down our 5n. Bring down our greater than or equal to. 15 plus 40 would just give us a new total of 55. All right, our next step is our multiply divide step where I have to check to see if it's a flip or no flip. So in this case, we're going to take our 55 and divide it by a positive 5. Since the number we're dividing by is positive, no flipping here. This stays greater than or equal to. Cancel on the one side. And we end up with that 11 is greater than or equal to n. Now, this is where people keep messing up because we want to put an 11 here and we want to shade to the right, but that's not correct because the variable's not in the front. So if you would tend to shade wrong for this one, off to the side somewhere, put your n in the front, put your 11 in the back, and flip-flop your sign because these 2 things have the same solutions. But this one of n is less than or equal to 11 helps me understand better that I'm going to have a closed-in circle here, and I should be shading to the left, right? I should be going towards 10, 9, 8, 7, all the way to negative infinity, not towards positive infinity, so be careful. All right, number 4, we want to solve for our variable m when we're told that negative 12 is every number less than or equal to 5m minus 4m minus 1. All right, in this particular inequality, there are parentheses or grouping symbols that we have to remove using our distributive property. So that's step one. Be careful here. This one that is outside our parentheses is really a negative one that's going to have to get cheered here to our 4m and our negative one that's on the inside. So be careful with your signs as you distribute. So we have negative 12 is less than or equal to 5m. Negative 1 times 4m will give us a minus 4m. And negative 1 times negative 1 will give us a plus 1. All right, now that our parentheses are gone, we have to finish our simplifying process by combining any like terms. So over here, negative 12 does not have a like term. These two terms both have a variable of m, so they can go together. 5 minus 4 would just give us m, or 1m plus 1. All right, if you choose to leave it like this as just m plus 1, which is the easier thing to do, then you have a one-step inequality to solve. If you put 1m plus 1, which is perfectly fine, then it's going to require you 2 inverse operations to finish the problem. Both will get you to the same final correct answers. So in this case, I'm going to leave it as simple as possible. All you need to do is remove a add 1 by subtracting 1 from both sides. All right, negative 12 minus 1 then would give us a new value of negative 13 is less than or equal to m. Since we were adding and subtracting, we didn't have to do any flipping. Now, here's where you need to be careful. M's not in front. So if you would normally put your negative 13 here and accidentally shade to the left here, which you shouldn't be, off to the side, put your m in front. Put the negative 13 in back and do the flip-flop so that you understand that m is really bigger than negative 13. That's what this means. If 13 is smaller than m, then m is bigger than 13. Those mean the same thing. Or excuse me, negative 13. So make sure, no matter if you're using this version or if you're using this version, they both mean I should be having a closed-in circle and I should be shading the solutions properly towards positive infinity, so be careful. All right, number 5, we want to solve for our variable x. When we're given negative 2 times 2x minus 4 minus 6x is less than negative 17. All right, we have parentheses here, so we need to start our simplifying process by expanding using our distributive property. We're going to take this negative 2 times and share it with our items on the inside. So we'll end up with negative 4x a plus 8, be careful there with your signs, that's a negative times a negative, minus a 6x is less than negative 17. All right, we're not quite done simplifying because we have some like terms here. So negative 4x minus 6x will give us a negative 10x plus 8 is less than negative 17. All right, we're at our most simplified version. There are 2 things to remove, a times and an add. So it's going to take 2 inverse operations. Cover up your x. I need to get rid of the add part first, working through PEMDAS backwards. So subtract, and the amount is an 8 from both sides. Adding and subtracting will never flip anything, so that's going to stay right now as a less than symbol. All right, negative 17 minus 8 would just give us a negative 25. All right, our next step is a multiply divide step that might cause a flip, so make sure you check for that. We need to divide both sides here by negative 10. Since this 10 is negative, this has to flip-flop on that step. A bunch of us still missing those when we need to do it on our activities, our homeworks, and so forth. All right, from there, our symbol now is a greater than the rest of the way. All right, negative 25 divided by a negative 10 would give us a positive, in this case, 2 1/2, or 2.5. All right, let's graph our solution. Since this is a decimal to the tenths, it makes more sense to count by tenths instead of ones, or maybe since this is a half, counting by halves. All right, we go 2 1/2, 3, 3 1/2, 4, right? Or 2.6, 2.7 getting bigger, and 2.4 and 2.3 getting smaller. All right, from there, we should have an open circle, and our solutions are to the right. All right, your job is, I'm going to leave problems 6 and 7 blank for now. I'm going to the on your owners. I'm hitting pause on this video, and I'm completing the on your own page. There's 6 of them. Try them. All right, hopefully at this point you've completed your on your own problems. If you have mistakes, please correct as we go. So number 1, we should be starting with combining like terms to get a negative 3z plus 5 is greater than 8. From there, subtract 5 from both sides. And then since we are dividing by a negative here, on this step, our sign should have flipped directions. If you only have it flipped on the answer, you would have a step that's incorrect, so be careful there. And we should have z as every number less than -1. So open circle, and we should be shading to the left. All right, number 2. Combine our like terms, and then this becomes a one-step problem where we need to divide both sides by 5 and 19/30. Is less than p. Remember, that's the same as saying p is greater than 3 1/4. So we should have an open circle, and we should be shading to the right. All right, number 3, we should distribute first to get our 16h minus 20h plus 28 is less than 7. From there, combine like terms to get a negative 4h plus 28 is less than 7. From there, we're going to subtract a 28 on both sides. And then again, when we get down here to our divide step, since we're dividing by a negative, on that same step, our sign should have flipped to a greater than sign. And we should end up with h is every number greater than 5 and 1/4. If you wanted to put your fraction version, or 5.25. So open circle, and we should be shading our solutions to the right. All right, number 4, we're going to start by expanding using our distribute property to get 8a minus 6a minus 15 is greater than or equal to 13. Then from there, combine like terms to end up with 2a minus 15 is greater than or equal to 13. From there, we're going to add 15 to both sides, or you could do what I have there of subtracting a negative. Remember, that's the same as if you just had positives here. All right, from there, we need to get rid of our times by 2 by dividing both sides by 2 to end up with a is every number greater than or equal to 14. Closed in circle and shade to the right. All right, number 5, we're going to start by expanding using our distributive property. And then combine like terms to end up with negative 20 is greater than or equal to 3y plus 4. From there, we're going to subtract 4 from both sides and divide both sides by a positive 3. So no flip here, and we end up with negative 8 is greater than or equal to y. If that messes you up for your graphing off to the side, remember that's the same as saying then y is every number less than or equal to negative 8. So it's closed in circle, and we should be shading to the left. All right, number 6. We should be starting with our expanding using our distributive property to get 2 2/3 x minus 1 1/3. So from there, we're going to add 1 1/3 and divide both sides by 2 2/3, no flip, and we'll end up with x is every number less than -4, open circle, and a shade to the left. All right, I hope that helps you with your activities for today. See you guys later.